Okay, so let's talk about this free response question real quick. So first thing I want to point out, there's a lot of information up here. They're really talking about 3 different functions that are somehow related to one another. So they've got f of x, and they gave me a graphical representation of it here. Then they gave me h of x, and they gave me just the equation representation of it. And then they gave me g of x, which is in the form of an integral. So we'll kind of decode that in a minute also. But before I would focus too much on all of that mess, the first thing I would do is read your question so that you know where to focus your attention. So on part A, they just wanted me to show that h of x, which is this one up here, is continuous at x equals -1. So then you have to ask yourself, okay, well, what do they mean by continuous, right? In order to show that something is continuous, I really have to know the definition of it. So if you look back in your textbook at page 87, it tells you what you have to show in order for something to be continuous, to prove that it is continuous. So the first thing you have to show is that the function itself at that point is defined. That's one thing. The other thing you have to show, so what I mean by that is there's not like a hole in the graph right there, right? There is an actual point at h of -1. Okay, the second thing you have to show is that the limit as x approaches -1 of h of x exists. So what I mean by that is if the limit doesn't exist, that's like that jump discontinuity where it goes like there's something that looks like this, where you have a graph and then you've got the graph up there. That's a jump discontinuity, right? So that can't happen. And then the last thing is the function at that point and the limit at that point have to be the same. They have to be equal to one another. So not only do I have to make sure I have an actual function that has a point there, it has to be the same as what the limit is. So the limit in this case goes here. My function at that point can't be there. It has to be up here in it. Okay, so that's what I have to show. So then the question is, how do I show that? So the first thing I would do is figure out, well, what is h of -1? So I would go back up here and look at my equations. This top equation is only helpful if x is less than -1, which it is not. So I'm looking at where it's equal to -1. So that tells me that h of x is actually g of x. So this is actually g of -1. That's what I should be looking at. Okay, well, if I look at g of -1, I'm looking at this piece right here. So that tells me I'm looking at the integral from 2 to -1 of this, f of t dt. Okay, so what that tells me is when I look at my f of x graph up here, I'm looking at this area under the curve. Remember, an integral means the area under the curve. So I'm looking at from 2 to -1. Well, first of all, I should notice that that is backwards. The smaller number should always be on bottom. So I'm going to switch that. I'm going to make that -1 up to 2. And there's that rule that if you do that, it's the negative area of that. So make that negative, switch your values. Now I'm looking at f of t dt. So I'm looking at this f of x graph, and I'm going from -1 up to 2. So from -1 up to 2, I'm looking for the area. Well, they already told me what the area was right there. So inside that curve, they told me that that area is 4. This one down here is 3. This one is 2. So if you looked at the problem, they told us that. They said the area is bounded by the graph of f of x, blah, 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 is 4, 3, and 2 respectively. So they're labeled in there. So this piece right here is negative that area, which was 4. All right, so I've shown what that is. I know that it's defined, and I know that it's -4. Remember, I have to, in the end, show that that is also the same as the limit. So I'm going to show that from both sides there. But right now, I've shown that it is defined. That's good. Okay, then I have to think about the limit. The limit exists if the limit from the left and the right is the same. So I really have to look at what is the limit as x approaches -1 from the left of h of x. And I'll do this kind of separately. I want to make sure I give myself enough room here. I'll try to squeeze it right here. So the limit as x approaches -1 from the right also. So these are like two separate things that I'm trying to find right here. Okay, so if I'm going to go from the left, remember if it's from the left of -1, that's where it's less than -1, right? So if I'm looking at h of x in that case, I'm really looking at this because it's less than -1. Oh, I'm sorry, you can't see. So this up here, I'm not looking at g of x anymore because this is the left of -1. So everything's smaller than that. So I'm just going to plug my -1 straight into that function. Oh, that's a minus. Okay, so you can kind of see what I'm doing there. All right, so this is 1, this is -3, this is -2. Well, 1 minus 3 minus 2 is -4. So if this one out down here comes out as -4 also, then I know that, yes, this is continuous. They pretty much already told me that it is. They're wanting me to like prove it, right? So that's how I prove it. Okay, so this last one is, I'm now going from the right, which means I have to look back at this again. So from the right-hand side is things that are bigger than -1. So that has to be this one. So I'm really looking at g of -1. That's what this one is. So if I remember your limits, you can just plug it straight in. So that's what I'm doing. I'm plugging it straight in. Well, I already found g of -1 up here. I already did that. And I got -4. So this is -4. I already know that. I don't have to prove it again. I just have to show it once. Okay, so once I've shown those three things, then I just need to state my answer. And this is where it gets kind of tricky. The AP exam is a little particular about how you write things. So I've shown all of it, I've proved it, but do I understand what I just did? So the way that I wrote my answer, I said h of x is continuous, and I'll just abbreviate that, at x equals -1 because, so I'm saying I know this because, and my reasoning is I know that the limit as x approaches -1 of h of x is equal to the function at -1. So that's how I stated my answer. I did not state in this answer that the function is defined and that the limit exists, but I did show that over here. So I think that's enough. I just need to make it really clear that I know it's continuous because those two things are the same.